Hi. It did not save when it crashed, but that leaves extra room for me to write. I don't know what you all are going to do. And I think I haven't done D yet. And so if I take a look at that one, I think I can write. So chlorine and oxygen. So I take a look at chlorine, and we have the 3 bonded, right? And 1 lone pair. So I come over here to electron groups. We had 4. We have 3 bonding groups and 1 lone pair. So my electron geometry is tetrahedral, and my molecular geometry is trigonal pyramidal. And we do both, okay? So tetra, that's obviously not going to work. I don't have enough room there. Electron geometry, and then trigonal. Okay, so we are always going to ask you the electron geometry. Just count on that. So just plan on giving both. This molecular geometry is the one that's going to be incredibly important when we talk about polarity later and whether or not something dissolves in something else. Okay, so that was just chlorine. So I said we have 2 central atoms, so let's take a look at oxygen. Do I have a little bit of space underneath here? Oh, I do. I'm going to use it. So oxygen, when I take a look at oxygen, we said that oxygen has these 2 lone pairs and it has 2 bonded pairs. Okay, still a total of 4 groups. And so we're still in the 4s, but it has 2 bonding groups and 2 lone pairs. So oxygen's electron geometry is going to be the same as chlorine's. But because it has a different number of lone pairs, the molecular geometry will be different. Now, the next time I video, I'm going to have these things put together. This is going to be one of the probably few times that I'm really going to wish you were in person so that you could play with these kits so that you can actually see how 3D they are. And it will help you understand how this works. But I hope when I do that on the next one. Again, right now, all I am worried about is for you to get number of pairs, groups around central atom, number of bonding groups, number of lone pairs, identify electron geometry, was my hand, and molecular geometry. Okay? As far as how that works in 3D space, just hold on. So this is something that you can take a look and do by steps, and then we'll get to the other part a little bit later. Okay? All right. So there's that one. And what you might notice is you have a different geometry set up here as well. So if you want to pause and figure out what the geometries around those central atoms are, then do that. And I'm going to give the answers verbally, so go ahead and pause. And so carbon has 4 groups. All of them are bonded. So both its electron geometry and molecular geometry are tetrahedral. Oxygen, again, 4 groups. 2 are lone, 2 are pairs. Down here, electron geometry, and it's bent. And you notice that's the same, right? That's the same as what we were just looking at. Yikes, I have no idea what I just did there. And I wish it would stop. Okay, so That's set up the same way, so they're both bent. Okay? All right, pause and do silicon dioxide. Silicon dioxide, when you take a look at this one, it has 1, 2 groups. And both of those groups are bonded groups. Hey, look, 2 groups, both bonded groups. It's linear electron geometry, linear molecular geometry. Okay? All right, so wow, there it is. Let's take a look here, and apparently I need to move that a little bit so you can fully see it. And that went away, so hold on. So sorry. Okay, so works the same way. I'm going to scroll it down a little bit. Maybe, maybe not. Okay, so on my screen you can't see the top, but in your book you can. So if you've got your book open, you can. All right, so like you saw, I didn't have any 5s. I don't have any 5s present, but you can see that that is an option, okay? And same process. So I'm just going to do a couple of these. So here my central atom sulfur has 1, 2, 3, 4, 5, 6 groups. They're all bonded. 6 electron groups, 6 are bonded. It's octahedral electron geometry and octahedral molecular geometry. Okay? I come back, I look at this one, xenon. 1, 2, 3, 4, 5, 6. We're still in this 6 grouping again. And then with that one, we have stopped working in. But you'll notice, let me move that. You've got 1, 2 lone pairs and 4 bonding pairs. Okay? And so when you scroll down here, please let me beat the thing, I'm not. 6, 4, 2 is right below here. So you see electron geometry is octahedral, and the molecular geometry is whatever is sitting right there. And that's how these work. Okay? All right, I'm going to figure out how to record and not have this problem happen. And you guys are going to work on chemistry and send me questions. Love you, bye.